Okay, welcome to the now uh, module 3.2 of the MOOC on Bioinformatics Essential. Now, in the last video, we run the blast for one sequences, and I will tell you I have taken the blast from the RPOB gene of the Mycobacterium tuberculosis. Here, I have made the note over here. You can see unknown one gene. The first gene is RPOB uh, of the Mycobacterium tuberculosis. So we got the results as per the our uh, sequence from the blast that we got the results regarding the. Just wait, I will show you the Google Chrome, and you can see here we got the results for Mycobacterium tuberculosis. The same gene we got as the result, or the more aligned and more perfect gene after the blast. So we are doing the right thing. Okay, here you can see the thing, blast, and here you can see the Mycobacterium tuberculosis. We got the results for Mycobacterium tuberculosis. Now we'll go to the interpreting the results. Okay. Now, what is an alignment? What is the meaning of alignment? So alignment places two sequences opposite to each other to identify corresponding positions that we have seen in module 3.1 also. Example, I am repeating the example. Query is MKTLLAV and subject is MKTLLAV. So matching residues can be observed directly. More complex will if we add the some complexity, you can see MKTLLA dash VG and subject is MKTL dash AAIG. So this gap is indicating the insertion or deletion relative to other sequences. Now, what is the percentage identity? Okay, percentage identity represents the reporting the proportion of aligned positions containing exactly the same residue. For example, query is ACGTAC and subject is ACGTGC. Now you can see there are six positions, there are six nucleotides in the sequence. Out of six, only five are identical. So therefore, if you do the maths, simple maths, 5 by 6 into 100, we got the result of 83.3% of identity. Now how we can interpret that? Higher identity generally indicates greater sequence similarity, means the sequence is very similar to each other. Now, however, identity must always be considered together with biological link, query coverage, e-value, and biological context. Means what is the alignment link, what is the query coverage, e-value, and okay, that thing we see in the next slide also. Query coverage. Now, suppose query coverage indicates how much the query sequence is represented in the alignment. Now consider we have the 500 amino acid long protein, and the result is shows 450 residues aligned. So that shows the coverage is 90%, and result B shows 50 residues are aligned. So that coverage that shows the coverage of 10%. Even if result B is very high identity, the biological interpretation may be different. So here key principle is high identity over a tiny region is not equivalent to high identity across most of the sequences. So now, very important, e value. The e value means expectation value. It will estimate how many matches with a score at least as good as the observed result will be expected to occur by chance in the database of the given size. Now, in general, if you are not getting this sentence or this statement, don't worry, just keep in mind, if we have the lower e value, then stronger statistical significance, a very small e value indicates the observed similarity is unlikely to have occurred by chance under the search model. Okay, that means your your results are not by chance results. Okay, they are the perfect results. If the value is very small, that means they are the perfect results, not a by chance results. Now, how this e value is influenced? Alignment score, database size, and search parameters. So therefore it should be interpreted independently. Now we'll go and we'll learn more about the e value. Imagine searching a database for a specific 10-letter phrase. Now finding a match by chance in a small collection may be unusual. Finding the same match in a massive collection may be less surprising. Okay. Blast accounts for the search space when circulating the e value. If you are not getting this statement, don't worry, I am repeating. Just keep in mind this rule is smaller e value generally means stronger evidence that alignment is not a random match. Okay. If you are getting the very low e value, very small e value, that means the computer has performed the accurate work and your results are good. Your results are considerable. You can consider that results. Okay, you can consider that match for the further study. Now bit score. Now here we can't see the bit score, but some tools may show the bit score. So the bit score provides a normalized measure for alignment quality. A higher bit score generally represents a stronger alignment. Means if the bit score is high, alignment is stronger. Unlikely e value, the bit score is less directly depend on the size of database. Okay. For our level, high bit score means stronger alignment, lower e value means stronger statistical significance. These two things we have to keep in mind. Okay, these two things. If bit score is high, stronger alignment, e value is low, stronger statistical significance. Now identity. What four numbers that we have to keep in mind? Identity means how many aligned positions are exactly the same. Query coverage, how much of the query is aligned. E value is how statistically significant is the match, and bit score is how strong is the alignment. So these things are there. So far, just for before closing this video, to one thing you keep in mind. Okay, your identity should be about 100% and your e value should be about 0. Okay, so if you are getting these things, that means your results are significant. You can use that match for the further work. So thank you for watching the video. Give the like, please subscribe to the channel and share the video with your peers, colleagues. Thank you. We'll meet in the next video regarding the multiple sequence alignment.